Hello and welcome. In this video we'll be covering calculator for the G500 and 100 devices. We'll start off with an introduction to calculator, followed by mapped points and calculator points, application parameters and basic syntax rules, expressions, evaluations, timers, analog assignments, digital assignments, quality conversions, type conversions, averages, and lastly we'll finish up with a look at output to input conversion. With that said, let's get started. Calculator is a built-in mathematical control logic tool to perform basic math functions on MCP G500 G100 data points to automate substation procedure, typically used to carry out the following functions: perform mathematical, logical, or timer-based operations on selected system data points, automatically operate one or more digital or analog outputs when certain conditions are met on the Calculator tab on the DSAS Editor's configuration page. You configure the Calculator automation application to select data points referenced in expressions called mapped points and build expressions. The calculator creates new points in the MCP system point database based on the results of the configured expressions. Once you've defined calculated points, they're available for selection when creating server maps, configuring alarms, and creating additional calculator expressions. All calculator-owned points are referred to in the expressions by a configurable alias name. The values of the data points generated by the calculator are evaluated each time a change event is received on one of the data points referenced in a defined expression. During runtime, calculated point values are presented to the operator on the Application tab on the Point Details page. The Mapped Points tab on the Calculator page is used to select system points to be used as variables within the calculator expressions. The left pane displays a tree view listing on the data points available in the MCP system point database, from which you can select as mapped points. Mapped points are organized under the data type subtabs: analog input, analog output, digital input, digital output, accumulator, and text. Map points that are selected in the tree view are added to the list in the center of the screen. Double-click the alias field within the list to change the calculator alias for the point. To delete a point, select the point and click the Delete button. Click the Delete NE button to remove all non-existent points that are referenced. Non-existent points may occur if a device containing the referenced data points is deleted from the MCP. Calculator points can be used to provide input into one or more expressions. Once defined on the Calculator points page, these analog output and digital output points are shown within the point picker tree on the expression builder. Calculator-owned points include points defined on Calculator points page as input into the expressions, and 2 points auto-created based on the results of the configured expressions. The Application Parameters tab allows you to change the way the timestamps are recorded by the calculator application and whether controls are allowed at calculator startup. Data change time tag parameters can be set to use evaluation time. When this option is selected, calculator uses the timestamp of the trigger event to timestamp the resulting point from an expression if the expression evaluation results in a changed point value. Use the trigger event when this option is selected. Calculator timestamps the resulting point with the time reported by the system clock after the expression has been evaluated. The default setting is Use Trigger Event. The Allow Controls at Startup parameter can be set to Only Pseudo Points. When this option is selected, Calculator at Startup allows the controls to be mapped pseudo points only. For all points, when this option is selected, Calculator at Startup allows the controls to all the mapped points. Disabled. When this option is selected, Calculator does not allow the controls at startup. The default value is only pseudo points. To create a valid expression, the following basic syntax rules must be followed in addition to the format of the specific operation types. Order of precedence. No special precedence is enforced on any calculator expression except where parentheses have been used. The calculator evaluates parts of any expression that are within parentheses first, and then evaluates the rest of the expression in a left to right manner. Calculator allows up to 10 levels of nested parentheses. Evaluation of nested statements occurs in an inward to outward manner where the more deeply nested parts of the expression are evaluated first. White space, you may insert any number of spaces between the operators and operands. The calculator ignores these spaces. To validate the created expression, you can click the Validate button to ensure the expression is valid. Once map points and calculator points are defined and the application parameters are set, you can now use the Expressions tab on the calculator page to create, modify, and delete calculated expressions. Up to 10,000 calculator expressions can be created. You construct expressions by combining operands and operators to produce a resulting point. You can use any defined reference points in expressions. Operands can include constants, system data points, and quality attributes. Operators include mathematical, logical, and bitwise operators. The expressions also define the point names and data types that are used to represent the resulting evaluation. To create an expression, click the plus button. On the New Expression window, select the type of expression you want to create and click OK. The new expression is added to the left pane. Select it to display the configuration window. To delete an expression, select the expression in the left pane. Click the Remove button. The expression is deleted. The following related actions can be formed to configure evaluations, timers, analog assignments, digital assignments, quality conversions, type conversions, averages, and lastly, output to input conversions. Evaluation expressions perform operations on reference points and store the result in a calculator-owned input point. Evaluation expressions are re-evaluated whenever a data change event is issued on a point referenced by the expression. Quality changes on reference points only cause re-evaluation if the expression is converting the change quality flag into a digital input, or if the quality change indicates that the reference point is coming online or has had communications restored. The calculator monitors the quality of reference points for changes in the questionable and invalid quality flags. If any reference point becomes invalid or questionable, the resulting point for any expression that includes that reference point becomes invalid. The following operations are supported in evaluation expressions: math operations, logical operations, bitwise operations, request type operations, and last but not least, if-then-else construct operations. More details and examples of these operations can be found in the calculator section in the software configuration guide. The calculator provides timer functionality to a resolution of 1 second. A timer operation is defined by two hold times: rising edge, false to true, and falling edge, true to false. Hold times can be positive or zero. When the result of a binary expression changes, calculator starts a timer based on the defined hold times. If the value of the binary expression stays constant for the entire timer duration, then the value of the timer expression evaluates to true. For example, if you want a calculator on digital input 14 to turn on when digital inputs DL9 and DL10 are the same value for more than 10 seconds, use the following settings. Target point type is digital input. Target point is DL14 with alias 14DI. Expression is 9DI equals 10DI. The rising edge time is 10 seconds. The falling edge time is 0. Result, the output of calculator on digital inputs will turn on after 10 seconds. Analog assignment expressions receive output of operations on reference analog output and input points and translate these into operations on mapped analog output points. Quality changes on the reference point are monitored in case the change in quality impacts the calculator expression. Assignment expressions support the same syntax as evaluation expressions on the right-hand side of the expressions field. For example, if you want to send the setPoint command on the mapped point AO0 if an event comes on the mapped point AL6, use the following settings. Target point is 0AO, while the expression is 6AI. Digital assignment expressions receive the output of operations on the reference digital output and input points and translate these into operations on the mapped digital output points. Quality changes on the reference points are monitored in case a change in quality impacts the calculator expression. Assignment expressions support the same syntax as evaluation expressions on the right-hand side of the expression. You can specify the output commands by these parameters: override operation, control routing, on target point, off target point, control type, pulse on duration, pulse off duration, and number of operations. For example, if you want to send the trip close command on the map point DO10 if an on event is received on the map point DL8, use the following settings. On target point is 10DO. On target control type is trip-close. Control routing is on target point. Override operation is none. Expression is 8DI. Converted points are a special class of pseudo-points that are created based on an actual system point. This section is focused on quality conversion in particular. Quality conversions take a mapped system point and reports a binary true or false based on a certain quality flag within that point. The MCP provides 22 quality conversion flags such as offline, overflow, test, etc., as shown in the image. For example, if you want to create an offline quality point conversion based on mapped analog point AL7, whenever AL7 is offline, the calculator-owned digital input point D15 you created for quality conversion is true. When AL7 is online, the quality conversion point D15 is false. Use the following settings. Quality attribute is offline. Source point is 7AI. Target point is DL15 with alias 15DI. Type conversion points change map system points from binary input to analog input, or from analog input to binary input, or from output to input, or from accumulator to binary/analog input, or from text to binary. Again, converter points are a special class of pseudo points that are created based on an actual system point. The MCP provides the following 7 types of conversions: analog input to digital input to analog input, analog output to analog input, digital output to digital input, accumulator to analog input, accumulator to digital input, and text to digital input. For example, if you want to create an analog input to digital input type conversion, a new calculator-owned digital input point DL20 is created where the value of the source mapped analog input point AL10 is converted to a binary true or false. Use the following settings. Source point is 10AI. Target point is digital input. Target point is DL20 with alias 20DI. Bit position is 0. Calculator supports both standard and time-weighted averaging on selected map analog inputs. Block averaging is a basic arithmetic average. Time-weighted averaging gives an average that considers the amount of time the point stayed at each value. Time-weighted average is used to reduce the influence of infrequent outliers. For example, if you want to calculate and report block average to the created calculator-owned analog input point AL33 for the source-mapped analog input point AL15 for every 1 hour, use the following settings. Source point is 15AI. Average type is block. Target point is AL33 with alias 33AI. Alignment is 00:00:00:00. Subblock divisor is 1. Sliding is not selected. Value extension is not selected. And lastly, period is 1 hour. Output to input conversion expressions enable master stations to communicate with each other by converting 2 types of calculator-owned points: digital output to digital input, analog output to analog input, digital input or accumulator. To convert inputs belonging to external applications and devices, use type conversion expressions. Output to input conversion example. If you want to convert the calculator-owned source digital output point DO12 to the calculator-owned target digital input point DL13, use the following settings. Source point type is digital output. Source point is DO12 with alias 12DO. Target point type is digital input. Target point is DL13 with alias 13DI. Lastly, I want to thank you for watching this training content video. And if you're looking for more great content, take a minute and check out the Resources Hub on the GE website. You can do that by typing resources.gegridsolutions.com into your browser, or just click the link in the description of this video and it'll take you right there. Thanks so much for watching, and we'll see you next time.